So for this question, you will notice that they gave you two cylinders A and B, but it's actually connected by using a tube between them and also a tap that you can open and close. So initially the tap is closed, meaning to say that the two gases here are isolated. That means the gas here is by itself, this also by itself, they don't mix. But towards the end of the question, you will notice they will open the tap and then they will mix. Okay, so that's the second part. So let's look at the next part. So you look at the question, right? They said that each cylinder has an internal volume. So the volume is the same for both. But the tap is initially closed and A has this number of moles and this temperature. Whereas B gives you the pressure and the temperature. So you notice straight away the temperatures are the same. So the first part of the question asks you to calculate the amount of substance, which is the number of moles in cylinder B. Now, in your ideal gas equation, the only ideal gas equation that gives you number of moles is PVs and RT. Alright, there's no other equation that gives you number of moles. So every time they ask you for number of moles, you start off with PV equals to nRT. So you substitute the pressure in B, which you know. The V in B, we should also know. And you want to find R is a molar gas constant you get from the data booklet. And temperature, you have to convert this to Kelvin. So how do you convert from temperature from Celsius to Kelvin? You plus 273. No need to plus 273.15 because the final answer is just 3S. Alright, so you don't have to put 273.15. So just add 273, you get 310 and you get a number of moles. So part 2, when you open the tap, they want you to find the final pressure in the cylinders. But this statement on the total amount of gas is constant is very misleading. Because some people interpret this total amount of gas is constant, so then they start using this formula P1 V1 over T1 equals to P2 V2 over T2. Now you can't use this formula. I tell you why. Because when you use P1 V1 over T1, you are going to use the values for cylinder A by itself. That means let's say you use these values. In this case, you don't even have enough information because you know the pressure. So most likely you're going to use for cylinder B. So you're going to use pressure for cylinder B, volume for cylinder B, temperature for cylinder B. But you want to find the final pressure when the tap is open. So on this side, wouldn't the gas combine with each other already, A and B? So that means on this side you only have B, on this side you got A and B. So is the number of moles on this side, which is just B, equals to the number of moles on this side, which is A and B? Not the same. So therefore we cannot use this. So then why do they say total amount of gas is constant? It means that initially your A and your B, whatever your values, when you open the tap, they add up. That means there's no gas leakage. That's all they're trying to say. It doesn't mean that you can use this formula. Okay? So what you should use is use PVs and RT. When you use PVs and RT, now, volume you must add up because now you're combining both cylinders. So your A and B each have the same volume. So you have to times 2. So you get the total volume. Because you're finding the final pressure when you open the tap, that means you must take two cylinders as one together. So you will take double the volume for each. Number of moles you must add up because here is number of moles for B, number of moles for A you have, so you add up both. And then R you don't add up, R is a constant. T also, please don't add up. T, because both are same temperature, so according to our topic last time in temperature, if same temperature you reach thermal equilibrium means also same temperature. So that means it's still 310. Alright, that's the way to solve. Now if you see the first part, they said the number of moles is given, volume is also given, pressure is also given, so find the temperature. So the easiest way is to use PV and RT because the number of moles is given already. Okay, and you find the temperature. Can you quickly do that? PV and RT. So in the end, right, you get your temperature as 694 Kelvin. So the next part, the gas is then heated at constant volume, so raising its temperature by 800 Kelvin. Now this is very misleading. When they say raising its temperature by 800 Kelvin, it doesn't mean your final temperature. Your final temperature is 800 Kelvin. What is your final temperature? 694 plus 800. Do you understand? Alright, be careful. So your final temperature is 694 plus 800. So calculate the molar heat capacity. Now you have not learned molar heat capacity in your second chapter, but this is additional. They can ask you a little bit. So you remember what is heat capacity, right? It's just heat amount, heat energy needed per unit temperature, right? Then when we talk about specific heat capacity, that is heat energy needed per unit mass, per unit temperature rise. So it's a per unit mass extra, right? That's for specific heat capacity. So when you do molar heat capacity, you're just taking the heat capacity divided by number of moles. So it's amount of heat energy needed per mole per unit temperature rise. So in other words, all you need is to just find the heat capacity and then divide by number of moles. So how do we find the heat capacity? Do you realize that they require 85 joules of energy? So that is the heat supplied, right? So that means the amount of heat energy supplied is 85, but you need to have per unit temperature rise, so you divide by how many? 800, right? So 85 joules divided by 800 will be your heat capacity. So for molar heat capacity, we divide one more time with the number of moles, which is how much? 5.2 times 10 to the negative 3. So your molar heat capacity, so take 85 joules divided by number of moles divided by temperature rise, so you get amount of heat energy needed per mole per unit temperature rise. Next one is final pressure of the gas. Now to find final pressure of the gas, you have two options. You can either use PV's nRT, or in this case, you can use P1 V1 over T1 equals to P2 V2 over T2. Now why you can use in this case is because your number of moles, which is this, is the same throughout. They never open the tap, they never mix any gas, they never let any gas escape. So you can use this P1 V1 over T1 equals to P2 V2 over T2. And since the change happens at constant volume, so the V can cancel. So you get P1 over T1 equals to P2 over T2. So you want to find the new pressure, which is P2. So then you'll be P1, the original pressure, which is this, over T1, the original temperature, which is 694. Then bring the T2 over, so you times T2, which is 800 plus 694. And then you get your answer. But you can also use PV's nRT, because I told you can use in any situation. So when you use PV's nRT, the P is what you want to find. The volume is the same, so no change. So you use back the original volume. And also no change, you can use back the same number of moles. R is 8.31. The temperature, don't forget to add 8.31 now. So we better write nicely, because some of the things missing a little bit. So this is 5.2 times 10 to the power. How much is the number of moles? 10 to the power negative 3. Is it negative 3? Yeah. And temperature 800 Kelvin. Okay. You notice you'll get the same answer for both workings. Right, let's look at the question here. So you see this equation, PV equals a constant times T. That means your PV over T is a constant, right? So when will this equation be valid? When is PV over T a constant? For constant number of moles, okay? You can write down for constant number of moles. Next one, can you use for any type of gas? Only for N? So you can say the gas must be ideal. Right? The gas must be ideal. Okay, next one. So here you have a gas cylinder. They give you the volume, the pressure, the temperature. That is for the cylinder, don't confuse, because the next part is for balloon. For the balloon, you have the volume, the pressure, and the temperature as well. But firstly, find the number of moles in your cylinder. So number of moles in a cylinder, I told you there's only one equation, which is PV equals to nRT. So can you use PV's nRT to find the number of moles per cylinder? Now when you substitute all the values of P, V and T, now don't forget the volume here is 4 times 10 to the power 4 centimeter cube. So to change from centimeter cube to meter cube is 10 to the power negative 6. Don't forget. Alright, temperature is already in Kelvin, so no need to convert. Then you can get your number of moles. Now the next part is a bit tricky. They're asking you to find the number of balloons that can be filled from the cylinder. Now most students, what they will do is they will find the number of moles in each balloon first. Okay, can you do that to find number of moles in each balloon? Okay, can you try that first? I'll show you what to do next. Okay, after you get number of moles in the balloon, Many people would just take the number of moles in the cylinder, which is just now was 415, then they divide by this, which is incomplete. Now why you can't do that? Because it's logical, because you know number of moles in your cylinder, you divide by number of moles in a balloon, you get how many balloons, right now? Why you can't do that? It's because you're assuming every molecule of gas in your cylinder can come up and fill up all the balloons. Is that true or not? Can you use up the entire gas in your cylinder until it's completely empty? You can't. You know why? Because gas can only flow from higher pressure to lower pressure. So you look at the initial pressure of the cylinder. The initial pressure of the cylinder was how much? What's the initial pressure of the cylinder? 2.5 times 10 to the power 7, which is higher than the pressure of the balloon, 1.85 times 10 to the power 5, right? So that's why the gas could flow from the cylinder to the balloon. But as more and more balloons are filled up, your cylinder will get more and more empty. That means the pressure will start to drop. Understand that? When the pressure of the cylinder drops to the pressure of the balloon, the gas cannot come out anymore. So you have to find out how much gas remains in your cylinder that cannot come out first. So how do you calculate that? Any suggestions? That means when the gas cannot come out already, right? What is the pressure in the cylinder? When the gas cannot come out already, what's the pressure of the cylinder? 1.85 times 10 to the power 5, which is the pressure of the balloon, right? So you calculate for your cylinder, the pressure now drops to the pressure of the balloon, which is 1.85 times 10 to the power 5. Use the volume of the cylinder. The R and the T same, find the number of moles. So this is the number of moles in your cylinder that cannot come out. Understand or not? Okay, to calculate this, then I'll teach you what to do. So the next step would be to find the number of balloons that you can fill. So you take the total number of moles in your cylinder, 415, you minus the 3.07, that means you minus the one that cannot come out. That means you will get the number of moles that can come out. Do you understand that? Then only you divide by the number of moles in each balloon. Then you get the number of balloons. So here you get about 740.9, I think. So some people say, okay lah, it's almost complete balloons to put 741. But you know, when you talk about girls, they're very, what do you call it? They're very picky one. They cannot chinchai one, right? So they say, no. 0.9 also not perfect enough, so I throw away. So then they get 740. Also can, they accept. So if you're a guy, you wrote 741, or girl, you write 740, also can.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with one or two past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.